Hello, everyone. My name is Gregor Giebel. I'm the operating agent of Task 51 Forecasting for the Weather-Driven Energy System. And this is the third out of 4 webinars that we're having throughout November. For the questions and answers, please use the Slido option that allows you to also uprank different questions. I'll post the link in the chat as we go. And with that, I'm letting Corinna Möhrlen, the task manager of the Task 51, introduce our speaker for today.
Thanks, Gregor, and hello and welcome everybody to our third webinar on uncertainty quantification and evaluation. And I will give a quick introduction to the topic within the task and also make a little bit of perspective of where we are coming from and why we are working on that. So, as Gregor said, the webinars are recorded and they are the first 2 are already available on our website. And if you go to slido.com, you can then also start asking questions. The uncertainty quantification is really kind of the DNA of our task because we are working in 3 work packages that start with the weather prediction and then the power conversion and the end use of the forecasts. And that's actually where we are coming from. We realize that looking at uncertainty really requires to look on the entire forecasting chain. And so that's why it's an essential part of our task to have the broad picture of that this is an overlapping task through all 3 work packages. And last year we had our main organization, the IEA, that brought the integration of renewables into phases. They defined phases, and now that we are entering in many areas in the world the so-called high phases, where the renewable energy production sometimes meets the entire demand, and then moving into phase 5 and 6. Meeting significant volumes and then is almost exclusively renewables. This is actually when uncertainty becomes a topic that nobody can close their eyes from anymore. And that's why we can say throughout the last 8 years of our task, we have been looking into the uncertainty, but it's like it's only now that the industry also realizes that this is a topic that everybody needs to get into. So that's just for your records. When we, as I said, when we come into the phase 5 and 6, then we have a lot of uncertainty to deal with, and that's kind of where we came from. In 21, we looked at where are the gaps and where do we have to work, and I made some circles around here. As you can see, one of the big topics was really the uncertainty and probabilistic forecast and uncertainty analysis and validation. And we realized that we have to bring all that into something that we can assist the industry, we can help developers, we can bring everybody on one table and discuss how we can solve and how we can quantify and qualitatively describe uncertainty. And last year we had a workshop in Vienna where we asked about uncertainty in AI. And also how uncertainty is used in weather or power forecasts. And what you can see here is most people have voted or not at all or gut feeling. And we realized that it's really time to get out to the community and work together on solving or helping the industry getting a grip on the uncertainty. In our extremes in the power system workshop in October, we had a similar question: what would help most related to or AI? Where do we get? Where would you want to have most help? And we have again evaluation, reduce uncertainty, analysis, and warnings. So it's something that is starting in people's minds. And then also another one, what comes into mind when you think about forecast uncertainty in energy markets. I really like that one here, needs to be tackled, and that's what we try to do here with this uncertainty quantification. And the work started actually quite a while ago in 2021 or end of 2021. We published a paper in this renewable and sustainable energy reviews, where we really went through the entire uncertainty chain, from the weather prediction and climate prediction uncertainties into the operational phase. So from planning into operational phase into the market phase, or we could say we're in the end use phase. And then let's say this is from a time perspective, but then from a vertical perspective, it's about the uncertainties starting in the weather and climate, then the input data to the power models, to the data quality controls, and the wind to power conversion, the different models, the different data, and so on. And then also into the delivery, where are the uncertainties when it comes to the end applications, also the end tools that are used. And from that, one of the editors or the reviewers had said, this is all very interesting. Now you have defined it, but you have to also quantify it. And then we said, yes, but this is the next step. We want to first define these uncertainties and then start to quantify them by creating tools. And that's also what we have been doing. We had already some verification or validation packages developed within the task and as part of the IEA Wind Recommended Practice book. And we have then also now on GitHub, both are available on GitHub. So this is just for the reference, and that everybody can find this. But and to give you an introduction, so these two tools, as you can see, I have put them in here. There are probably a number of other tools already, and we have been working on creating tools to then actually bring this into a quantification test environment. And Ji Yan from North China Power University has then taken on the challenge to actually design and develop such a platform where we have now the basic validation and verification methods inside the platform, and that we want to work on to also allow others to plug in their code in the future, so that we can have a shared platform for the verification and the quantification of the uncertainty, where we also put in examples. So this is kind of the start and the introduction to that platform. We will then also, of course, try to make a publication to describe the process on how to work through that platform and how it can be used. but now we are kind of at the starting point of that, and with that I also want to hand over to Chi, who is going to introduce you to the platform now. So Chi, I think I'll stop sharing and I'll let you share your screen.
Okay, thank you. Let me share the screen.
And while Chi is bringing the presentation on the screen, I just want to remember again that we have the Slido open and you can ask your questions already or put them in if you have them while Chi is then talking. And with that, I think, Chi, I'll hand over to you and we can see it fine now.
Is it the right screen you can see now?
Yes, we can see.
Yes.
We can see your presentation.
Thank you, Corinna. So yes, I should have done this platform and let it go into the testing process earlier, much earlier than now, but finally we have a preliminary version, and I will give you some introduction and about the platform and what is the preliminary results we get from the testing from the real data. Sorry, I think there's something timing here. So the overview of the platform will be like there are basically three main functions in this platform, which is you could do the analysis about the power focusing error and do the trace up about the uncertainty sources, like what Corinna just mentioned about the paper. We already built up a structure about how to trace, how to uncover the uncertainty from power forecasting, from the weather data model and so on. So we just bring that structure over here and give out the quantification method. You could just use this as a tool and upload your data into the platform and get results from the platform. This is the first one. The first function has already been done in this platform. If you can see, this is the web page of this platform. When you get login and you could use it easily. And when we have more and more people to use this platform and upload more and more data and model, we could also give out a comparison or even ranking about different model and different data, and then hopefully we could also give out some of the improvement strategy or suggestion about to all of the model who upload to the platform. So hopefully we could firstly give out the quantification and the diagnosis about the power focus error, and then to tell people or suggest the people how to improve your accuracy according to our analysis about the error and the uncertainty sources. So this is the web page and the address of this website, and I will also print this, show this in the final page as well. You will benefit from it no matter who you are. For example, you are a forecaster, or you are just a focused product users, you can know your error, you can know your focusing uncertainty better, because we can give you more comprehensive view about the error, like the distribution and the distribution under different scenarios, and then give you more suggestions to what you can do to improve your accuracy according to your uncertainty. What kind of uncertainty is larger for your model, and you could do more efforts on that. Or you are just researchers or even students, just a beginner who in this field, you can firstly learn how to analyze and understand your results and get more model, more data to compare your model and your results. Or even you could use this as drawing the picture in your, as a tool to draw a picture in your papers or in your reports. Hopefully, maybe this will get more and more standardized models, standardized data. And in the paper, and the reviewers hope to see some very standardized comparison cases. And hopefully we could do someday to achieve that, and more people can use that and get benefit from that. How to use this platform? So now we have two functions. The first one is the error analysis, and we have two blocks over here. The first one is a simple one, just give you overall error statistics, like RMSE. You could get the picture to show how it looks like monthly, yearly, or seasonally. And then also you could get some refined into the detail about the error evaluation, like the error distribution under different scenarios, different forecast horizons, and different weather process, weather types. You could see, what situation you can do better for your model, or maybe you just get very large errors in some particular scenarios. Then you can put more efforts on particular scenarios instead of you just put some too much efforts on some no benefit area. No matter what kind of error analysis you want to do, you must do firstly do two selections. You can just click this by clicking these blocks. Like firstly, you need to choose what kind of the look ahead time, the focus horizon you want to analyze, maybe ultra short term or short term. The definition about ultra short term is over here. For example, like the ultra short term, like from 15 minutes to 4 hours or 6 hours, the resolution is 15 minutes, and here is the power. The real-time forecasting over here, I hope to give some particular explanation. It is real-time means that's the time resolution of this your focus results should be within 1 minute, like the minute scale focused or even second scale focused, who will be used in the control, farm control or turbine control. So here we didn't specify like here it must be power focus. It can be also wind speed focused or wind direction focused. That will be very regularly used in the controlling field. So, and also here I also put this here, hopefully to also give an open area for the task 44, or maybe in the future some other here. And the second thing you have to do your selection before you do the analysis is you choose some metrics. Here we provide 4 metrics, but of course we could add more on that as more as we like. We put 2 mainstream metrics like RMSE and normalized RMSE and MAE. We are now putting into it is it is ongoing. We put into the maximum error also here, but still working on that. And hopefully maybe some Chinese focusers or focus users could also use that, and we put some particular metrics from Chinese state grid. And when you go into the platform, you could click here to see what is the equation of each matrix. So after you do these 2 selections, then you could select what kind of analysis you want to do, and you also select these things by click these blocks, and when you click this, and the color will turn into blue, and you won't see nothing here in this screen, but after all you will have one step to click the generate the report, and you will see all of the figures, all of the explanation about the analysis about this figure will go into the report. So yes, why we do that, I don't know why, but it is the most easiest way we could develop this platform. So yeah, I also hope maybe in the future we could like active feedback. When you click this, they can generate the figures in the screen directly, but at the moment you have to wait and generate the report and download the report. Here the detailed analysis or the detailed analysis include like the error distribution and the different fluctuation, and maybe very strong fluctuation or very smooth fluctuation. Maybe you could see different error distribution, especially when you do the time series focused, like ultra short term and real time one. And also you could, for this kind of focused, you also want to pay attention to the error along different focus steps. And then in the short term or medium term, you could see the power error distribution and the different NWP error, or also you could see some power fluctuation things, and then some like the positive or negative bears distribution for your focus results. Oops. Jump to. And then it's very important to upload your data according to the template. You could see on the screen here, you need to download the data file, the template file over here, and it's just simply a CSV or Excel something. There are many examples data over here. You delete that, you delete all of them, just leave the item, the name of this column over here, and then put your data over there after that, and then upload that to the platform. And also here, if you like, you could also tap into the country, province, or even to the area about your data, but if you don't like to open that information, you can just ignore this, get rid of that. The data here, the required data must have the measured the real power data and your power focus results. And here you could put into power, if you have different results from different models, you could also put them into that, like here true and after all is model 1, model 2 or something. You could see it in the template file. And then you could go into the final one, but very, very important. You click this generate report, and this is the content. You need to, maybe you need to wait for a while, like minutes, and then the results is available to download. All of the figures over there you could see. I will show the results afterwards, and now I go into the second function is how to trace, how to uncover your uncertainty. The uncertainty, all of the definition, all of the uncertainty sources, we are all of the things are follow the basic the paper, the basic idea from this paper. Corinna also mentioned that in her slides. And the uncertainty sources are include the weather, data, wind to power, and the model. And then we somehow try to quantify firstly each of these uncertainty like this. For example, quantify the weather. We try to use NWP error as the main one. Maybe not that much accurate, but at the moment in this platform, this is the easiest way to put into that. And another one is we hope to also quantify the weather itself. Maybe it's easy to get track his the trend of changing. Maybe not that much, maybe difficult to track that changes. We try to use this auto correlation thing to quantify that, but at the moment, maybe it's not that much useful at the moment, but we still leave it here. So, and the second one is the data uncertainty, data quality, and the representative of the data. Or the details about those definitions, you could go back to this paper to see them. And wind to power one, and then the model uncertainty. First of all, you need to select what kind of sources you want to trace. Most of the people want, I suggest you to click all of them, but if you don't want the more thorough analysis you hope to get, which means that more data you need to upload. So that is why we make these uncertainty things separately, because not all of the people want to share their data in that much level. So you could see also under these uncertainty things to see what kind of things we need to we use to define and quantify this uncertainty, like whether it's NWP and autocorrelation data means the reasonableness, completeness, and the representativeness, and the power curve width, and the model fitting things. And second one is also upload your data according to the templates. And here, yes, like here, see different models. ST1 means short-term focus results. This results from model 1, and ST2 means the short-term focus model 2, and VT1 means ultra short-term focus model 1, model 2, model 3. It depends. Yeah, you don't have to upload more than one model result, but if you like, you could use this to compare the results. Here are the things that we encourage people to upload the training data and the testing data, but if you just don't really want to specify what kind of data is used as the training sample, which one is also okay. You can just simply put that into that. But if you want to put also your model into that, that will also give you more in-depth analysis. But if you don't want, it is not compulsory. Oops. Shut. Here I would like to introduce, if you don't want to upload many data into that, what method we will use to trace the uncertainty, and if you want to upload more data or even the model, what kind of method we will use to trace your uncertainty, to quantify your uncertainty. So this is the basic idea, just to use some algorithms like sharp things, those ranking algorithms. There are a lot, but we found the sharp is the best one. And to rank the importance of different uncertainty sources before we quantify the uncertainty sources by using here this information, these things. And then after that, after the ranking, these algorithms can also give out the proportion of these uncertainty sources account for the whole errors. So here is the basic idea about that. I will show the results afterwards. And if you want to show more data or more model over here, we could use some another methods, the variable control methods, which means that we conduct many power focus tests by successively eliminating the influence of individual uncertainty sources according to the uncertainty chain. Like we eliminate the NWP part error, we use the real wind speed instead of the NWP to put into the model and generate a new error result. And then after we use something like, yes, you could see here something, when we examine the data thing, we use the uncleaning data to do the training, and then retest the model and see how the data cleaning will be influence the final focus result, and so on. I don't go into the detail because afterwards I will give the result example. And then the final step is also to generate the reports here. And yes, when you do the reports download, you will see something like this, and you just click it and save them in your computer. Okay, here is some example. We do simply 3 cases over here, including short-term and ultra short-term. So they are from all of the data are from the real wind farms, and 3 models means 3 different forecaster, different companies, and they very kind to provide the testing data and upload them into the platform and do the test first. Here is the things about what kind of data they upload and what kind of reports they download. So the first case is the short term. So all of them are very simple to upload their measured power, NW data, and also the measured data, and not only the measured power and also the measured wind speed, and their focus results, and then to see the basic statistics, especially the monthly, because in China, people, the state grid published every wind farm according to their monthly arrows, so they are really pay more attention on that. And then to detailed evaluation about in what scenarios the arrow is large or small. And the ultra short-term one, we also have 3 models, and these 3 models have different input types. If my memory is correct, 2 of them just use the historical data to do the time series, the forecast, and the other one, the last one, also involved use the NWP wind speed in the ultra short term. And they are very kind to mention that when they upload the data. But this introduction about your model input types, it is not compulsory to put into the platform. And they are very interested in the average error distribution under different fluctuation scenarios. And the last case is from another wind farm, another region, and there are more models to be was uploaded. And if my memory is correct, they not just download the error distribution, but also the uncertainty traces one. So maybe here some mistake over here. Yeah, I believe they also download the do the uncertainty sources, uncertainty analysis part. Here's the results from our report from test 1, and you could see that they compare 3 models over here, and you could easily see that model 1 is in most of the months performed worse than the other 2, and yeah, I don't go into details. That this is the very basic analysis. And these are the error distribution and different NWP errors, and using different way this scattered approach, probabilistic distribution analysis, and box plot. And then is to see how the power fluctuation will influence the final result. Over here, this is also from text 1. And this one is from text 2, and this one is interesting, that this model 1, model 2, model 3, and these are results from the stable weather, and this one is from the unstable transient weather scenarios. And we found that the time series, the focus method, can work better than the other in the stable weather. And for the unstable weather, the NWP involvement of NWP data contribute a lot to a better accuracy. So this is interesting. So also give guidance for the focus users. They just buy two focus results from different companies and switch them in different weathers, and in this way improve their accuracy in the market. And this is a test case 3, and also for the ultra short term, you could see is different focus steps from the first 15 minutes to the final 4 hours. Over here, just different 2 types of plots, but both of them are also show the arrows changes along different time step focus steps. Yes, this is the case study also from test case 3 about the uncertainty part, and this is how those figures are also will also displayed in the report. You could see how large of the basic situation about your weather arrows and the autocorrelation of your weather, of your wind speed. This is the data, how we define the data uncertainty. The first one is how you do the cleaning and the eliminating data, how much data you will how much data you clean it, eliminate, put them out of your training samples. We just calculate the ratio of that. But if you don't upload the raw data and the cleaning data, we cannot do that. So that is why we hope we encourage people to upload more data and write more information about that. So this is the basic. This SBD is an index to quantify the data representative. It also requires you to upload and clarify which one is your testing data, which one is your training data. And this is also a picture to show how much representative about your data. And then this the wind to power one, and it's try to calculate the width of the observed power within very small wind speed bins, like the IEC standards has a very clear way to define to calculate the power wise under different wind speed bins. We just follow that. Model uncertainties is, as we said, we just put the calculated arrow and training sample running on exactly the same sample, running again your model and to see what is the result. In this way, to demonstrate the fitting performance of your model. This is a 2 model, so they are not very good, but you could also see the difference. This is when you train the model using these samples, and you put these samples again in your model, and these blue dots are the forecasted results. So, and compare this blue one to the green one, the RMC is 8%. So we use that 8% as the model uncertainty, the fitting error. This is the final result you could get from the platform. So this is the ranking, the ratio of each uncertainty sources, and the pink one represents the data. This also, the purple one is the NWP, and this small, very small green one is the model, and this blue one is the wind to power. If you see the ranking here, NWP is the top one, data top two, and then the wind to power, and then model and other things over here. And we try different methods over here. Most of the data and most of the methods show very similar results. NWP rank number 1 and data number 2, and so on. So hopefully these results can somehow verify that we give a relatively good method to do this as a standardized platform. In the end, you are very welcome, very welcome to test and give comments. And here is the website. And yeah, I have to admit this is a very preliminary version, and I found that it's really difficult to develop a very user-friendly and smoothly platform. So if you have any problem when you do the test, you are welcome to contact me through this, either of that email address. Thank you.
Thanks a lot, Chi. That was a very interesting introduction to the platform. And I think we can see, as Chi said, it's a work in progress, and it's just the first version. And I think we all have to bear with starting up. And we can see there are a lot of people that are clapping their hands. So thanks for that. I think this has to become a community task, and I'm really happy that we have a working version now, and we can develop it, and we can bring this into our next phase in the task, and work further on it. So G, first of all, thanks a lot for that enormous work you have put in there to make this possible. And then I think we should open up to the questions. And I can see one of the question, maybe if there is somebody here that wants to directly ask a question, you can just raise your hand and open your microphone and maybe video. Otherwise, we just go to the Slido question. So I'll start with that maybe. One of the questions that is probably important to clarify whether the tool is working with spatial data or time series or specific points. So you have shown some examples here, Chi. Maybe you can explain what am I going to do if I have, let's say, 10 sites that I want to evaluate. Do I then have to run it for all 10 sites, or can I also make a summary of that and put all the data into one file and get this evaluated?
Yeah, if it's 10 sites, I suggest you upload it separately. Yeah, everybody, when you use this platform, you need to generate your own account. So at the moment, this is the only way I can think about to try to protect your data. So you can generate your account, and then you could see different sites under your account. You will not influenced by other data or other sites. So please just because different sites will have different data types or data distribution, just separate them. Yeah.
So if I understand that correct, then it's like it's up to the user to generate the, let's call it the CSV files. So if you have an area that you want to evaluate, so an aggregated forecast, that will
Oh,
at the end of the day also just be a time series, and then you can feed it in that way. Or if you have individual points, you just create different tests.
yeah, I guess so. Yeah, yeah, you can use this as your way. Yeah.
Okay, and then I just jump to the next questions, and this is in the very beginning. There is the selection with the real time, short term, ultra short term, and so on, where it says 15 minutes
Mm,
data resolution. What do I do if I have 10-minute or hourly data? Do I have
yeah,
to convert it to the 15 minutes for the moment?
yeah. When I do the presentation, I realized it doesn't have to be 15 or 10 minutes. You just a time series is okay. Mm.
Okay. So the system is kind of um, generating the averages and all the statistics from the data, the time that is provided. You just have to have the time steps and
Yeah.
the
Yeah,
so
even
then
hour is okay. You just provide the time series data, and because the RMSE has to be time series, it doesn't
yeah.
matter what kind of time resolution. Yeah, we need to clarify that it's hourly or 10 minutes, 1 minute is both of them are okay.
Yeah, because I think this is an important thing, whether you have to format your data before you put it in, or whether the system in it by itself recognizes which time resolution it is and then provides the correct
Mhm.
statistics. The next question that we have here is different weather models have different uncertainties.
Mm.
Is this somehow considered in this evaluation tool, and can the model be selected somewhere?
Well, that is the most tricky one, the weather one. Yeah, we hope to do some more in-depth analysis, but it requires people to upload more too much. You know, when you talk about the weather, is the volume of the data is extreme. So now we just in this platform we just simplified the weather things to the NWP data, NWP error, and now in this platform, you have to upload at least one source of the NWP. But if you upload more, yeah, I also need to try that. If you because the model things you can upload 1, 2, 3, 4, 5, but NWP things, I need for me, I also need to try that whether the file can recognize different type. Yeah, I also I
Yeah, so maybe we can also ask the Met people here in the audience, but also those that maybe see the webinar later on, that if there are certain evaluation, verification metrics or uncertainty quantification tasks that you would like to see in this platform, then just get in touch with us, because then we can see how we can maybe integrate this. So, because one of the questions I also had that I kind of want to work on is that you can make a thorough analysis also from one part of it. So like if I'm interested in the uncertainty of the weather or only in the power and not care about the input data, but have different models, power models that I want to test, that there is a clear distinction of that I can also take only one part of the chain out of and then make a verification. But yeah.
Yeah, when you click different blocks and the upload data part, you will see a small red star to show what is the compulsory data you need to upload. So different combination of the blocks will show different compulsory. Yeah, but the logically they are they should be correct. But if you find some mistake, just let me know. Yeah.
Yeah, so then we have, I think, the last question here that is on the Slido. How are the fluctuating scenarios defined? Is this done automatically, or does the user need to enter this information?
You just put into the time series power or time series wind, and they will calculate that. I think there are 3 index over there to quantify the fluctuation. The first, the easiest one is the standard deviation of the a certain time slot power, and there are something like how to calculate the ramping rate or something to the combination of them to define the fluctuation scenario.
Okay. Yeah, so that makes sense. So we do not have any more questions here. Is there anybody here in the webinar that has a question to G?
It seems that like you were having a different Slido than I had.
Oh,
Because I
okay.
have different questions here. One was is the you're using terms like short term, ultra short term, and medium term. What horizons are they covering?
Yeah, the in the platform under this ultra and the short-term things, we try to give a definition. The focus ranges like ultra short, like from 15 to 4 hours. But I think it could be also extend to 6 hours thing. But yeah, and the short term is next day to 1 day ahead or 3 day ahead, and medium is from 1 day to 10 days, and long term is 12 months or longer.
Thanks. And the other question is how to trace the uncertainty from different sources. In my view, they are coupled together and communicated to the final forecast. And you had that one slide where you showed an attribution that in your example, there was a NWP and data had the big influence, and the model and the power to wind to power conversion had a very little influence. And how do you actually do this distinction?
Yeah, I think I need a share screen to help me share. Maybe this one you mentioned. I quickly. Yeah, is it one you mentioned or this one? Oops.
Yeah, I think it was further back when you had the examples.
Yeah, but it's stuck.
Okay, but it's that SHAP algorithm.
Yeah, SHAP algorithm. Yeah, here. Yeah, so because here we only have 4 kind of data over here. Yeah, actually we do a questionnaire in the community in China to see what kind of, at least I give you this platform, what kind of data you want to share at least. Otherwise, no share data, no analysis, no results. So these 4, they are relatively unsensitive. So we try to find some way to use these 4 kind of data to do the uncertainty trace. So we use the what is the I also here the NLP wind speed arrow here. This is the one feature, and then the data representativeness, which I mentioned that SBD, the coverage rate of the samples of the data. And then the wind to power. This is the second. This FBD index is the second feature. Wind to power uncertainty. We use the weight of the power under each wind speed bins to represent the wind to power uncertainty. And then the model one here is very tricky. We just use the real data to put into, God, can't remember how to do that model uncertainty. Anyway, here we have 6 features. We use these features to put into the SHAP model, and also the real power and the focused power, and the SHAP algorithms, train it, and then to generate the ranking of different features. Each features represent each uncertainties, and the result is what you can see.
Okay, thanks.
Yeah. Maybe I stop sharing and then
do we have any final questions from the audience directly, maybe? That doesn't seem to be the case. So I would like to thank you, G, for an excellent talk, for all that work that you did in putting that platform together, which was, I know, a lot of work, and for staying up so late to give this webinar. And I also thank Corinna for this introduction and the wider framing of it. And to the rest of you, we are having another webinar in a week's time that on the recent extreme events workshop and some of the results that we had for extreme events in the power system. And with that, good morning, good evening, and good night. And see you next time.
See you.
Yeah, bye-bye.
Bye-bye.